Alright, so in this video we will be talking about series and sequences, specifically testing for convergence or divergence. So all the questions in this video will be asking whether the series diverges or converges. So in this first problem, it asks if this series converges or diverges. For this one, you would need to use the nth term test. And the nth term test says that if the limit as n approaches infinity, a sub n does not equal 0, then the summation of that diverges. So for this example, you would need to take the limit as n approaches infinity of n over 2n plus 1. And so I would take out a 1/2 and you would get n over n plus 1. So this to infinity would equal 1 because you have infinity over infinity plus 1, and that would equal 1. So the answer is 1/2. Now, because 1/2 does not equal 0, the series diverges. Alright, so that's the first example. Now, the second example asks if this sequence or series diverges or converges. And to do this one, you would need to use the geometric series test. So we recognize that this is a geometric series, and your first term is 0.3, and you would need to find your r in this case. So your r would be 0.1, and the r is just whatever you need to multiply to get to the next term. So you multiply 0.3 times 0.1 and you would get the second term, and then so on and so forth. And because the absolute value of your r, which is 0.1, is less than 1, the series converges. Now, if the question asks if you want to take the sum of the series, you would do the initial term over 1 minus your r. So you would have 0.3 over 1 minus 0.1, which would simplify to this, which simplifies to 1/3. So it just asks if it converges or diverges. So the answer is that the series converges due to the geometric series test. Okay. So this is another example of asking for or testing for convergence. For this one, you would need to use the integral test. So the integral test says that if a function is continuous, positive, and decreasing, and your f of n equals the a sub n, then the sum of the a sub n will converge only if the improper integral converges. So for this one, you have to take the integral of the function. So this is what your setup is going to look like. Whoops. So in this case, you would do the integral from 1 to infinity, and instead of n over e to the n, you would do x over e to the x dx, and that would equal the limit of b to infinity, because you need to apply L'Hopital's rule. So here I just moved e to the x up to the top. All right, and then this would equal the limit as b goes to infinity, negative e to the negative x, 1 plus x, and you're evaluating that at 1 and b. So I would take out the negative right here, put it on the outside. You would get 1 plus b over e to the b, since you're substituting in b. Whoops, sorry. There we go. Minus 2 over e. So when you take the limit to infinity, you would get 2 over e. So because this integral converges, this does indeed converge. Okay, so the next example is an example of the P-series test, which in my opinion is one of the easiest tests because you're basically looking for the P, which, here. So in a P-series test, you have your infinity, n equals 1 over n to the P. If your P is greater than 1, it converges, but it diverges if P is less than or equal to 1. So in this case, your P, all you have to do is look at the format, and so you would see that your P is 3. Okay, your P is 3. And because 3 is greater than 1, this converges. So that was a pretty simple test. All right, in this next one, this is using the comparison test. So I write comparison test. In the comparison test, you're essentially looking at the function and relating it to any other function and how you would deal with it. So we see that this function, 1 over 1 plus n to the 4th, is similar to 1 over n to the 4th, or likewise 1 over n, or to any other exponential value. And because 1 over 1 plus n to the 4th is less than 1 over n to the 4th, this series converges. So if you have your the function that you compare it to has to be less than the function that you're comparing it to in order to converge, and it will diverge if the function is greater than the function that you're comparing it to. This might be a little confusing, but having it done a bunch of times, it's easier to recognize which functions to compare it to once you practice it. So, right, in this next one, you're going to be using the limit comparison test, and it says that if the limit as n approaches infinity, a sub n, b sub n is finite and non-zero, then both these functions, both the summations of these functions will either both converge or both diverge. So for example, in this question, this is basically like the same thing as the limit it's like the same thing to the comparison test, except you're using limits, and so you would do 1 over 2n plus 1 is less than 1 over n, so you would take the limit of n as n approaches infinity, 1 over 2n plus 1, 1 over 2n plus 1 divided by 1 over n. And then when you simplify, you get the limit as n approaches infinity, n over 2n plus 1, which equals 1/2. So because you know that 1 over n diverges, you also know that 1 over 2n plus 1 also diverges. So this diverges. Okay, in the next question, it asks if this series converges or diverges, and for this question you would need to use the ratio test. So this is the 7th example, so there are like a total of 9 different tests that you use for convergence. In my opinion, I think the ratio test is very simple, because what it says is that as the limit as n approaches infinity, a sub n plus 1, so the subsequent term over a sub n equals L if it exists, and it converges if the value of the limit is less than 1. And it diverges if the limit is greater than 1. And if L equals 1, then the test is inconclusive and you have to go on to another test. But this test, like I said before, works fairly well for a lot of problems. So going back to the original question, so you would need to do the ratio test. So you would do the limit as n approaches infinity as 1 over n plus 1 factorial, because this is the next term, over the initial term, 1 over n factorial, equals limit as n approaches infinity, n factorial over n plus 1 factorial, which simplifies to 1, which simplifies to 1 over n plus 1 equals 0 once you take this to infinity, because you have 1 over a very large number, infinity plus 1, so that would be closest to 0. So because it equals 0, 0 is less than 1, so this series converges. Okay, in this next problem, you need to use the nth root test. And the nth root test is pretty similar to the ratio test, but instead of dividing the two functions and taking the limit, you're taking the limit of the nth root of it, hence the name. So this is what the rule looks like. So you take the nth root of your function, and it converges if L is less than 1, and then diverges if L is greater than 1. Again, if L equals 1, the test is inconclusive. So for this one, you take the limit as n goes to infinity. Take the nth root of the entire thing, n over 2n plus 1, because that is your original function. The limit okay, so 1/2 is less than 1, so this converges. Okay, so you can see that like just doing these problems a bunch of times and getting the practice, you'll be able to recognize which test you need to use. For the AP test, I would probably recommend really knowing the ratio test well, and I mean you need to know all of them, but the ratio test is really helpful. All right, last problem. In this series, to test for convergence, you need to use the alternating series test. Okay, so the alternating series converges if two requirements are met. The next term needs to be less than the first term for all n, and the limit as n approaches infinity of the function equals 0. Okay, so for this one, you would see that you can write out the terms of this series, but it just helps to like recognize what to do. So you would recognize that this series is basically this. And this is a true statement for the entire series. So that requirement is met. And then the limit as n approaches infinity of 1 over n equals 0. All right, so that was the last problem. If you have any questions, go to the coffee shop for tutoring. And all of these examples are in the Barron's book. They're a part of the Chapter 10 lesson. So if you have any further questions, you can see it in person rather than in a video. But I hope this helped. Thank you.